All right, so okay, so we are going to graph y equals x squared. One way you can graph any equation, however complicated, is just to plug numbers in. Okay, so in this particular case, I want to be careful how big a number I plug in, because if I plug in like 7, what is 7 squared? 49. Is that going to fit on my graph over here? It's not. So let's just start with small numbers. So if I plug in 0, what is 0 squared? 0. So that would be the point right here, 0, 0. If I plug in 1, 1 squared is 1. Evan, you're doing a lot of talking today. All right. If I plug in 2, 2 squared is 4. So that would be the point 2, 4. If I plug in 3, 3 squared is 9. That would be here. Anything beyond this is going to go off on my graph, right? 4 squared is going to be 16. That's going to be too big for me to graph it. So this is part of my picture. I need to plug in some negative values. What do I get if I plug in negative 1? Positive 1. Negative 1 squared. Yep. So negative 2 is going to be positive 4. That'll be this point right here. And negative 3 is going to be positive 9. So that gives us these points right here for this graph. Okay? And so this makes what I will probably call our parent quadratic function. This is like the most basic quadratic you can have, right? It's just y equals x squared. It doesn't have any other numbers involved, any other x's, nothing else. It's just y equals x squared. So a lot of times when we're talking about transformations, we call this the parent function, because it's just like the most basic square root that you can have. And then we can take that parent function and we can do things to it, like shift it up or down or left or right. We can flip it upside down. We can make it skinnier or fatter, and all sorts of stuff like that. We're not going to look at everything with that, because it's we don't have to look at all of the different possibilities for this. But this is what this graph looks like. So let's look at another graph that is going to be very similar, but a little bit different. Okay? So we're going to do the same thing we did for the last problem. We're going to make ourselves a table. Okay? But this time my equation is y equals x squared minus 3. So if I plug in 0 this time, I'm doing 0 squared minus 3. What do I get when I do 0 squared minus 3? Negative 3. So 0, negative 3 would be right here. If I plug in 1, I will get 1 squared minus 3. It's just 1 minus 3. That's going to give me negative 2. Okay? 2. It's going to be 2 squared minus 3. That is 4 minus 3, which is 1. So 2, 1 will be right here. If I plug in 3, I'm going to have 3 squared minus 3, which is 9 minus 3, which will give us 6. So 3, 6 would be right here. I'm pretty sure if I plug in 4, that's going to go off the graph, so I'm going to leave it there. Now, much like the last problem, if I plug in negative 1, now I'm going to have negative 1 squared minus 3. Negative 1 squared is the same as positive 1 squared, right? Because when you square it, that negative is going to go away. So you're going to get a negative 2 here. So they're symmetric, right? So rather than plugging in all the rest of these numbers, I can kind of just look and see that this is going to be symmetric here. This will be symmetric here. And then I will graph. So Isabella said that this really is like the same graph we just had. It's just been moved down. How far did it move down? It moved down 3. What do you see about the equation? You see a -3 over here at the end. And so what it did is it took all our y coordinates and it just subtracted 3 from them. Right? What they were, right? Which just moved the whole thing down 3. Okay? So what we're going to look at today is how we can tell what type of movements we've made with this quadratic without actually having to graph the whole thing. Yes. Okay. So what we just observed was a vertical translation. When a function is moved up or down. And for a function to be moved up or down, if we put a plus a number, k right here could be in like 7 or 10 or negative or positive 2,143. We could add anything to this at the end. It would move the function up that many units. So if we put a plus 10 on the end of something, it moves that graph up 10. If we have a minus k right here, then we're going to move that function down that many units. So like that last one we just looked at had a -3, it moved that graph down 3 units. Okay? This applies to all functions, not just quadratics. We're going to mainly focus on quadratics, but we're going to see some that are not quadratics. Okay? So if I look at number 3, I'm supposed to describe each transformation. So I see right here that I have an x squared. And x squared tells me that I have a quadratic. Then I see my -5 over here. What is that -5 going to do to this graph? It's going to move it down 5. So shifted down 5. I mean, I don't care all that much. Okay? All right. Questions on that? All right. Our next one, once again, we've got an x squared. So that x squared tells me that this is still a quadratic. Okay, what's happened to this one? It's going to be up 8. The 8's in the front. Does that matter? It is not, because could I write it this way? X squared plus 8. Would that be all right? Be the same, right? So this is going to be shifted up 8. Do we have a quadratic on number 5? We do not have a quadratic on number 5. What do we have there? What type of equation is this? There's a special name for an equation that has an x in the exponent. We did quite a bit with them. We particularly looked at them with like interest in a bank account or decay or growth. What were those called? I think I just heard it. Exponential. All right. So when we have an x in the exponent, this is an exponential. Function, and what's happened to it with that plus 9? Shifted up 9. Now, it'll look very different from a quadratic. Exponentials, have that shape where they increase really rapidly. So it would take that shape and it would move that whole shape up 9 units for that. So these rules that I'm teaching you for quadratics also apply to other functions. What in the world have we got on number 6? Silly. What is this? Oh, kind of, but not really. Not really. Is this a quadratic, a linear, an exponential? Okay. Evan is correct when he says he has no idea. We don't know what this is, right? Because f of x could represent any kind of function. It may even be something that we don't know about yet, like a cubic function or a square root function or an integral defined function from calculus or something crazy, right? It doesn't matter because these rules apply to all functions. So if we see a f of x, we just call it f of x. It's some mystery function that they named f of x. It doesn't matter. Putting a -7 on the end of it is still going to do the same thing to that function as it would do to an x squared. What does a -7 do, Rosalind? Down by 7. So shifted down 7. Okay. Ian, what are we dealing with for the last one? What type of function have we got? That one's an exponential. It has a different base than the one on example 5 had, but it really doesn't matter. It's still an exponential. And what has happened to it? Very good. Shifted up 12. Okay, questions? All right, now, up and down are not the only directions we're going to be concerned with. All right, so I think I'll just graph these on Desmos for us. Okay, so I'm going to graph y equals x to the second right here. That's sort of like our reference. That's our parent graph, right? Then I got y equals x plus 3 to the second. All right, so x plus 3 squared, and then y equals x minus 5 squared. All right, let's just look at that x plus 3 squared first. What happened to that graph right there? Okay, it went to the left how far? 3. Now, look at your equation. Is there anything kind of strange about that? The equation said plus 3. But it went to the left, which is like the negative side, right? Okay? So that, let's take note of that. Let's look over here at this green graph. Okay, this time I had a minus 5. Which direction did I go? To the positive direction. I went to the right 5. Okay? So, what we should notice about this, it's opposite, right? And what you'll see as you learn more about these rules, because we're just kind of scratching the surface here. This is something that we do a lot of really in really in every class past here. So you'll look at quadratics and I don't think you do trig functions there. Trig. You do some trig in Math 2. But you do like triangle trig in Math 2. You do some more advanced trig in pre-cal. Mm-hmm. Yeah. So you'll see this more with different types of equations. So you'll see this. I do a lot with it in pre-cal also. I mean, we still reference back to it in calculus sometimes. So you'll see this more in these rules apply all the time. But anything on the inside of the parentheses just works backwards from what you would think. So if you put plus 3, it actually moves it left 3, right? So for horizontal translations, f of x plus k, where k has to be a positive number here for this, then that's going to move this left k units. And if we have f of x minus k, that's going to be right k units. And this is whenever we see this on the inside of the parentheses, not on the outside. So let's look at some examples, and we're going to describe each transformation. Okay, so if we look at example 8, we see right here that we've got a square. That square tells me that I'm dealing with a quadratic still. Even though I don't see the square right there with my x, there is a square that would square that x, like if we wanted to square this out. So I have a quadratic. This time my 9 is on the inside of the parentheses, not the outside. So I'm going to have this quadratic move to the right 9 units. Okay, so is it still a quadratic? Yes, so quadratic. Evan, what have I got for number 10? Very good. I tried to mix it up a little bit to trick you, to make you think that it was left or right because it's in the section with left or right, but that 5's not inside of a set of parentheses, right? So it's just moving it down 5. Oh, what is 11? Okay, Ian tells me it's exponential. I agree, because there's an x in the exponent. Now, do we see any parentheses here? But it is like, because that x plus 3 is all in the exponent, it's like we've got parentheses around that exponent, right? In fact, if I wanted to type this into Desmos, we might have to put those there. So this would be left 3. It'd be good if you did. If you don't, I can move it. Okay. So, and what type of equation are we dealing with? You still have a square, so this is a quadratic. And that minus 4 is going to go to the, oh, was it left? Right. 4 and down 3 units. Okay. 13. Aiden, what type of equation is 13? We'll just call it f of x. We don't really know what it is, so we're just going to call it f of x is shifted right 2 units. Okay? I'm ignoring you because you're answering all of them today, Isabella. That's good, but yeah, I'm still going to ignore you to get the other ones involved a little. All right, Blakeland, what have we got on 14? What type of function is that? 15 would be an exponential. 14, I've got that f right there. So, like, we don't really know what type of equation that is, so we just call it f of x. And then, Blakeland, what would that plus 3 on the inside of that parentheses do? On the inside, it's going to move it left or right, and it goes in the opposite direction of what you have. So for 3, since we've got positive 3, it's going to go left, which is the negative direction, 3. So it's go on the inside of the parentheses, you're going to go opposite of what you have. And then on the outside of the parentheses, any numbers added or subtracted on the outside are going to shift up or down, and they go the direction you think they should go. So up 5. So whatever f of x looks like, it would shift left 3 and up 5. Okay, Giancarlo, what type of function do we have for our last one? This is exponential. What has happened to it? Right 2 and up 7. Perfect. We were testing some stuff for prom decorations. We'll probably not use those exact lights, but our idea, I think, is going to work. Okay? Questions? All right, there's one more type of transformation we are going to talk about. There are some other things that you can do for transformations, but we are not going to talk about them. So I'm going to graph these first two right here together. Y equals x squared and y equals negative x squared. What happened there? Flipped it, right? Okay, let's try the next two. I'm going to graph x minus 4 squared, and then I'm going to graph negative x minus 4 squared. Flip. Okay? And let's try one more thing. X to the second plus 5 and negative x squared plus 5. Yep. So when we have that negative right there, it's going to flip that quadratic upside down. All right? Now, I will say this. The flip happens first. Then the shift up, down, left, or right is going to happen. It doesn't make a difference on the first two because they're on the x-axis. But like this one, if you think about it without the plus 5, this would be just the parent graph. You would flip it first by putting that negative there. Then you would do the plus 5, which would move it up. So that is what it's going to look like there. So, for these, a reflection over the x-axis, if you have negative f of x, it's the reflection of f of x over the x-axis. Reflections must take place before any translations. So we've got just a few more to look at. Okay? Now, I don't like problems that look like number 16 because I don't like this 10 to be over here. I did make this problem. But I know that you may see this, so that's why I made it this way. So I can show you how to deal with ugly problems like this. So I don't like this 10 right here. How could I rewrite this so the 10's not at the beginning? Why does it not let me write? Negative x to the second plus 10. That is the same, right? I can switch this order as long as I keep signs with the numbers they're supposed to go with. So what do I have here, Aiden? Okay, quadratic. I'm going to use the fancy language for this, reflected over the x-axis, which does essentially just mean flipped upside down, right? And then what else happens to it, Aiden? Up 10. Good. You do want to put the reflections first, so the reflection happens first. That negative right there is a reflection. Caitlin, what have I got for number 17? What? Quadratic, good. Okay, and what has happened to that quadratic? Okay, you got two things happening right here. So you got this negative out. Why is it not? It's like it's stuck. It won't even let me erase. Look at this. Alright. There we go. We got that negative and we got this minus 4 right here. So what did we just say the negative is going to do? Reflect. So this is also going to be reflected. Still the x-axis. You are correct. It has to be inside the parentheses for it to reflect over the y-axis. And that's not really something we have to look at in this class, but you will look at it in some class, like in the future. Okay? Reflected over the x-axis. And then, Caitlin, when I got that minus 4 on the inside of the parentheses, is that going to move up, down, left, or right? It is going to move to the right. 4. Okay? Isabella? Yes. Okay, I agree. The negative is what reflects it over the x-axis. Yeah. So whenever you look at this, you're going to still just call it f of x. But that negative is one of the transformations for that. And then the 7 is the other. All right. 19 is about the hardest thing I'll give to you. You won't really see anything more difficult than 19. Okay. I just don't like problems that have this like number up front right here. What can we do with it? We can put it back here on the end, right? Negative x plus 3 squared. It is a positive 9, so we can put plus 9 there. It is a quadratic because of the square. Okay, Lexi, what all has happened to this one? Mm-hmm. Left 3 and up 9. I did. Okay, questions? So basically we got 3 things that can happen. All 3 of them happened in this particular equation, right? We have negatives are going to flip stuff over the x-axis. We have adding or subtracting on the inside of the equation is going to move our graph left or right. And then adding or subtracting at the end of the equation moves it up or down. Okay? And there are other transformations, but that's all we have to worry about in this class. Okay? So your assignment is going to be on Delta Math, and it is 10 questions. I think it's 10. Might be 8. And you're just going to go through and answer these for me. It is set up sort of like, because I entered these questions myself, Delta Math didn't have a lot on this. So it is set up where, like, if you miss it, it's not going to let you go back and redo another question for that. So now, these may be a little bit tougher. That asks you to write the quadratic equation of the quadratic below. When it says give your answer in vertex form, I should explain vertex form means that you have, like, shifted it. So let's do this first one together. What has happened to this quadratic? What's happened? It's been moved right 3. So when I write my equation for that, I'm going to have y equals, does the 3 need to be on the outside or the inside of the parentheses? Inside. So x plus 3 or minus 3? Minus 3, I need to do the opposite direction, right? So if I want to move it to the right 3, which is the positive side, I need to put the negative right here. What else do I need for that? Square it. And you can just do shift 6 and put that square. And you'll submit that. So it should give you the right answer. So answer these real quick. Hello? Yes. You're welcome. Isabella, it's you. Office. I don't think so. You're not leaving, it didn't sound like. I don't know what they need you for.
What?
I bet it is Mr. Willis. It's about time for you to drive. Maybe at the end. Let me look at the. I'll look at that. Also, if you get this finished, even though I don't know, Isabel said it wasn't working. I need to take a quick survey for you guys. I sent it to you yesterday, the gravity one. Did it work? Okay. All right, if you have not checked your email from me, let's do this before, because I just want to go ahead and get that done. It won't take but a second. Go to your email. There should be an email, like a Google form that says gravity survey. And I want you guys, there's just 3 questions, and I want you to answer those 3 questions for me. It has to do with what we're doing tomorrow. let me change it. I'm going to change it so it shows you if you got it right or not after each question.